Okay, so my name is Isidora Šašić. I'm a data scientist here at HTEC Group. And today, as Costa said, I will talk about synthetic data. So a couple of months ago, I attended a data science conference here in Belgrade. And I heard about a startup that is developing a synthetic data generation platform, which was very interesting to me. And I really wanted to look more into that topic and explore it a bit more and try it out on some real data. So this work has been brought to you by not only myself, but also my colleagues, Ogi Milicevic, who is machine learning tech lead here, and Marko Radosavljević, senior machine learning engineer. So today we will talk about synthetic data, what it is, what it's used for, what are some limitations related to it, and also I'll mention some use cases and industries. And later we will talk a bit more about mostly AI, so that's the startup I mentioned, about their platform, how that synthesization process goes, and I'll show you some results on some real data. So this first part of the presentation will be more general talk about synthetic data, so anyone interested in synthetic data to know something a bit more about it. And the second part will be maybe more interesting in someone that is dealing with data on a day-to-day basis. So engineers, data scientists, and so on. So when we talk about synthetic data, there is a common catchphrase, data is new oil, which is not so new anymore. But I think we're all aware that in order for companies to prosper and thrive, they really need access to data. And with today's situation that data is growing rapidly day by day and really increasing in volume exponentially due to huge amounts of devices that are made, but also due to complex infrastructure that enables all that data flow. That's on one side. But on the other side, we have a regulatory complexity that is increasing. And that's not only in case in the EU, but also around the world. And we have that situation that customers are indeed being more interested in how their data is handled within organizations. So how it's processed, where it's stored, and how it's shared. And some even say that privacy will be one of the key components, one of the key factors why people will buy the data products. So let's see why we use synthetic data. So the first thing that pops to our mind is probably the privacy. And here we are talking about the trades-off, actually. Like in every engineering process, there is a trade-off also here, and that's between data privacy and data utility. So maximizing data utility means that you want to get as close to as you can to the original data. So you want to preserve all the patterns, all the correlations, all the structure. But on the other side, if you get too close, you might jeopardize the privacy. So it's really a balancing matter of balance. And no data platform actually will guarantee you 100% data privacy. So it can also be a matter of availability. So in some organizations, you don't have access to data due to some regulations. Also, there are organizations that are handling sensitive data, and you might not even have enough of it. So you just might have a portion of it, and you really need to scale up your solution. And that's where synthetic data really kicks in. And scalability is also one of the key factors for successful companies. synthetic data really enables you to generate it at any scale you want, whenever you want, and for whichever purpose you need it. Of course, when we talk about machine learning algorithms, there's a huge open space for synthetic data there to be used. So we know that today's ML algorithms use a bunch of data for training purposes. And one specific case is, for example, if you have a data set with rare events, you can upsample those rare events and really be creative and create those what-if scenarios, and really test your solutions on the data structures that are still not available in original data. And that's common use case in, for example, fraud detection and in defense industry, where it is very important to act in time, to act on attacks that did not even happen yet, so that you can only create. And finally, we come to the resources, time and cost, which always plays important part in companies' success. So synthetic data really can decrease your time to market of your products, and mostly data products. You don't have to wait for those lengthy procedures to, have a bunch of papers signed for you to use the data. And in terms of cost, this is a big data platform, so you can really reduce the cost by generating a bunch of data if you need it. So also there are other techniques for data anonymization. So when I was talking about synthetic data specifically that is created by machine learning, here we have some, let's say, data masking, data generalization techniques, other pseudo-anonymization techniques, but they all have one drawback in common, and that's they're easily identifiable. So there is actually one-to-one connection between original data and anonymized data. So it gets down to either private data or useful data in case of anonymization techniques. And with synthetic data, you create a completely new data set. So there is no one-to-one connection to original data. And here you might think that this picture, in this picture, it is a girl from the street. But actually, if I didn't put this explanation underneath it, but actually it's generated by NVIDIA's generative models. So it's completely artificial. And it really shows all the benefits that I just mentioned. It can be seen that all the key components, all the key structures are preserved, the texture, so all that nonsense are there. But yet it's a person that doesn't exist. So you cannot trace it back to original data. And yet I didn't have to go through some procedures or through some waiting process for consent to use this picture in this presentation. So this is just a basic example of how synthetic data works. Of course, there are some limitations. So with synthetic data, basically all the key strengths are also the limitations. So first of all, as I mentioned, there is no guarantee that your data will be 100% secure. So it's rather a fact than a limitation. It's a fact for any synthesization algorithm. And basically no company that is in this business will tell you that, but it's true. And you should really know your data well and use case in order to choose which to choose that trade-off or balance, how much security you need, or maybe you don't need it at all. Of course, there is no reverse engineering, as I mentioned, and you might think, well, that's exactly what we wanted in the first place. But that really depends on the use case. So sometimes you might need, at first, you might need to anonymize the data set, do something with it, but at later stages, you would want to go back in time and expose those individuals, and that's not really possible here. So this is a big data technology, so it's not suitable for small data sets. And it really makes sense when you think of it, how those generators work. So I mentioned that they are preserving the structure. They are actually looking for distributions in the feature space. And it's really impossible to do something like that with small data sets. For example, in my last project, my colleague and I were working on a data set of around 900 individuals. It was a health tech project. We had dozens of features, but really we had so much information about those individuals that we could have made hundreds of features, no problem, if we wanted to. And if we were to synthesize that data set, it would be a bunch of outliers, and it would be basically useless. So if your valuable information is hidden in outliers, this is not a way to go, because these platforms are treating outliers as vulnerabilities in the system. So outliers are actually exposing those subjects, those individuals. So let's talk a bit about the use cases, so where it is specifically used, and mostly in the financial industry. I think somewhere I read 8 out of 10 top US banks use it, and mostly for improving fraud detection. It's also used by Amazon and Google, and basically in all that large system that use a bunch of data to train their ML models, for example, customer purchase prediction, where Amazon already has the data, but they want to enrich it with some artificial ones, and they want to create those what-if scenarios that I talked about. Google's also using it for self-driving cars. And the synthetic data found its way in the health tech industry, and specifically because in the health tech industry, data is very sensitive. And there are strict regulations and privacy policies, and you really, synthetic data, I think, really found its purpose there, and that is going to grow. And Russia, for example, is using it mostly for clinical research. That's one of the use cases. So now that hopefully I explained why you should use your synthetic data platform of any kind, now we can head to mostly AI. That's the startup that I mentioned. So they were formed back in 2017, I think, by data scientists. They have developed that platform for synthetic data generation, and they're mostly specialized in structured data. So basically, any kind of tabular data is okay, where one row represents one subject. And I'm going to talk a bit more about that, how that synthesization process goes, through which phases, specifically on their platform, what you get as the output, yeah, let's head to it. So first, original data is fed into their platform. So you upload your data, and then encoding process starts. So that basically data pre-processing. There is inferring data types, data ranges, protection against outliers, both for categorical features, but also for other types of features. So you are 100% sure that no outliers will expose the rows or individuals. And then the data is tokenized. Tokenized data then go into a training process where the architecture is being developed based on the data. Tokens are encoded into vector representations. And then the real substance is, the real process is really learning the conditional probabilities in feature space. So both for independent data points, but also for sequences. So the algorithm is trying to learn the distribution of features. So once we have ML model ready, the generating process can start. So basically, they're generating the data according to those learned conditional probabilities, and you have your synthetic data ready. So that's not the end of the process, because that synthetic data needs to be somehow evaluated. And evaluation is happening in this analyzing phase, where it is being compared to the original data, and that's based on accuracy and security. And then you have your data ready together with QA report, which tells you if your synthetic data passed all the tests. So I'm going to tell you a bit more about that QA report, because there are some, I think, valuable information that it gives you. But before that, I'll tell you what my colleagues Marco and Ogi did, and they did a prediction of unplanned C-sections based on electronic health records data and cardiotographic signals. And why did they do it in the first place, aside from being paid for that, of course, is this came by surprise to me, but the US is one of the leading countries in maternal mortality in the industrial world, which has to do with numerous socioeconomic factors, but also due to their health problems, obesity, diabetes, and so on. That's so that's a little bit about the background of this work that I did. And for this purpose, this presentation purpose, I will use this first setup. So EHR model trained on EHR data alone. And that's basically because it's structured tabular data, so very suitable for this use case. And CTG signals are very different. They're time series signals, and they're much bigger in volume. So EHR data is electronic health record data, tabular data. In volume, it's about 100K of rows and around 30 features. And the problem that they were solving is, given a set of EHR features, predict the delivery method. So it's a basic classification problem with two classes. And now before, yes, so this is the evaluation flow. So my idea was, okay, let's see, we have a model trained on original data. So let's see how it works with synthetic data that is based on that original data. So we have a pregnancy data that is being split into a test and validation. In validation, or in training data, actually, we have two streams. So we train the model on original data in one stream. In the second stream, we synthesize the data and then train the model on that synthetic data. Then we test the model with the original holdout data. So we can compare those two scenarios. And before I go and present some results, I would like to talk a bit more about that QA report that I mentioned. So what does it look like? It has several sections: privacy, accuracy, and then correlations and feature distributions. So first of all, it tells you if your synthesized data passed the privacy check, and there is basically there are three metrics that are being calculated. So identical match share, which is actually calculation of identical matches between records in original and synthetic data. And also they're calculating some metrics. I think this one is the distance to closest records, and this one is just a normalized distance to closest records. So they're measuring the distances between the records in the synthetic data set and their closest records in the original data set. And it gives you a percent, and if your synthetic data is passed that privacy test. So that's the first one. The second one is accuracy. So it tells you how accurate your synthetic data is, and that's measured by some statistical distances between records. And it's done both for univariate and bivariate distributions. And here you can see they show you the accuracy metrics of these joint features. Then it shows you the correlations. So you have a correlation matrix for original data and synthetic data, and their difference here, where you can see how they differ, where there are maybe some differences, where it's exactly the same, and so on. And finally, it shows you the distributions, feature distributions. So it gives you distribution per feature, but also these joint distributions here. Here I showed you mother's age and BMI group, and their joint distribution here. Actually, you can see one of the limitations that I mentioned before, and that can be basically seen in this 7th BMI group. As you can see, the distributions are quite different between two original and synthetic data, while in groups from 0 to 6, they're very similar. And that's basically because here it can be seen that the number of records for this 7th group is quite small. I think it's maybe 6 or 7 records. And for the other ones, it's thousands of records. So it's really big data technology. And going back to our evaluation workflow, so the model that is trained using XGBoost, and the test metrics that are used are standard precision recall and F1 score for unbalanced data sets, because that's the case here. And let's see, for the end, let's see some results. So here we have a confusion matrices for original data and synthetic data. And we can see that they're pretty much similar. They differ a little bit in this recall measure for unscheduled C-sections. And it's better seen maybe here. When we talk about accuracy, it's both it's both 87% for synthetic and original data, which I think by this we really show that in certain use case, so this is a HTEC project, this is original data, we have comparable results of ML model trained on both original and synthetic data. So I think we showcase that synthetic data can be valuable. And for the end, I would like to highlight some key takeaways. Well, first of all, synthetic data is on the rise, and that is going to continue in the future. In my opinion, So synthetic data platforms and are really reducing time to market of your products. It enables a more free data flow within organizations. It reduces costs for big data projects, but also increases the scalability of your solutions and makes re-identification super difficult. So not impossible, but super difficult. And before you choose your data platform for generation of synthetic data or any other anonymization technique at all, you should really know your data well. But you should know your use case even better. So you should really know where your information is hiding within that data. So what is the purpose of your data? So what you want to do with it. You should know, for example, if it's hiding in outliers or not, to be 100% sure if you can go with synthetic data. You should make sure if privacy is a matter to you or not. And sometimes it's not all about fancy platforms and neural networks that are being fed up with huge amounts of data somewhere in cloud. Maybe you don't need that much resources. Maybe you can go with some regular anonymization technique. It is all a matter of use case. And when you choose your synthesization platform, you should test it thoroughly on all data that you possibly can, and then you should really be sure that it's working in your case. So that's all from me, and I'm open to any questions.
Thank you, Isidora, for this. For now, we don't have any questions. I'd like to encourage you once again to ask them down in the chat. We have a comment from Ognindo, who says, no question, just wanted to thank you for all your hard work and general awesomeness. It's worth reading.
Thanks,
So until we get any other questions, I might start on a couple of things that interest me in particular. So my first question would be, how usable is this process in a live environment? So is there a possibility to, in near real-time or real-time, create synthetic data for certain systems? Or is the process of creation taking somewhat more time and it's not really usable in those situations? And what are your thoughts on that?
Mm-hmm. Yeah, so specifically this platform is using generative adversarial networks. So it really depends on the volume of your data. For example, for this use case, for this 100K of rows with some 30 features, it took around 3 to 4 minutes. So it's not really real time. And with neural networks, I think we're all aware that it's not really possible to do it in real time. And this is not such a huge data set at all. So if you had like 1 million of rows and I don't know, hundreds of features, it would take even more. So in my opinion, that's not possible with this solution.
Thank you for that. And I have another question, and that is it possible to combine synthetic data with some other forms of data manipulation to expand the things you can do, like, for example, data augmentation processes and stuff like that? And would there be any risks or concerns with combining different techniques?
Well, I mean, it is. Why not? But I cannot think of the use case for such a scenario. So it's always either you're using some technique. Maybe you thought about some statistical augmentation techniques, or maybe something like that. And generally, I think GNAs are more for big data. But if you have some use case where you have maybe smaller data set, then data augmentation might be better case. I haven't used it in like a combination, but I'm sure it's possible.
Yeah. Thank you for the answers.
No
We have another question in the chat from Igor. He's asking, can this approach be applied for simulation of test data instead of training data?
So the question is, can you repeat?
Sure. Can this approach be applied for the simulations of test data instead of training data?
Sure. Yes. You can, I mean, you can generate whatever you want based on the training data, based on the test data. You can even generate more samples than you have. So you can, upsample some of the classes. If that's your use case, you can play around with it.
Hope you're satisfied with that answer. Any other questions? Okay. If not, Isidora, thank you very much for a great presentation.
You're welcome.
And we will see you again soon.
Okay, thank you all. Bye.